Okay, let's get started. So today's Tuesday, March 19th. I hope you had a nice Monday with no school. Today we're going to continue right along with Eureka Math Module 4, Lesson 27. We're nearing the end of Module 4. Module 4 is a really long module. I think there's like 32 or 33 lessons, so we're getting to the end, okay? And today we're going to take everything we've learned about fraction division. In Lesson 25, we learned to divide a whole number by a fraction. And then in lesson 26, we did a fraction by a whole number. So today we're going to take all of what we know and use it to help us solve some word problems. So today your learning goals, I can solve problems using or involving fraction division. For example, your problem of the day says, Mrs. Silverstein bought 3 mini cakes for a birthday party. Okay, instead of buying one big cake, she decided to buy 3 mini cakes. She cuts each cake into quarters. So how many pieces does she cut each cake into? Interesting, okay. Fourths, because 1/4 is 1/4. And plans to serve each guest 1/4 of the cake. So if Rupa came to the party, she would get 1/4 of the cake. If Melvin came to the party, he would get 1/4. Lucas would get 1/4. Charlotte would get 1/4. Prisha would get 1/4. Okay. How many guests can she serve with all of her cakes? Draw a model to support your response. So the first step was to write down what the question's asking. What is the question asking us to figure out? Paulina? Yeah, we want to figure out how many guests will get cake. Okay. What important information do we need in order to figure that out? Tarun?
She bought 3 mini cakes.
Okay, there's 3 cakes.
And each guest will get 1/4.
Each guest gets 1/4. And we need to draw a model. Good. So let's draw a picture. Here's one cake. Here's another cake. And here's the third cake. Yes? She cuts each cake into quarters. That cake is now into quarters. This cake is also in quarters. This last cake is now in quarters. Each person is going to get 1/4, so let's see how many people will get cake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many people will get cake? 12 guests. Now, did we do some dividing here? Yeah. Let's write the division equation we did. We said there's 3 cakes all together. And are we sharing or grouping? We're not sharing because we're not doing 3 divided by 12. We don't know how many guests we have to share with. But we know how big each serving is. How big is one serving of cake? It's 1/4 of a piece. So we're splitting it into 1/4 sized groups. Does that make sense? We're trying to figure out how many fourths fit inside 3 cakes. And how many 4th size pieces were there inside 3 cakes? 12. Okay, so if you didn't write down the equation yet, go ahead and write it down. So far, we've learned how to do 2 kinds of division. They all involve 2 components. One component is a whole number, and the second component is a unit fraction. So we've done whole number divided by unit fraction. We've also done unit fraction divided by whole number. Okay. And I want to remind you how we can draw pictures to do both kinds of fractions. So in your notebook, set yourself up. On one side of your paper, write a whole number divided by unit fraction, write 5 divided by 1/3. And then on the right-hand side, write the opposite, 1/3 divided by a whole number, 1/3 divided by 5, a unit fraction divided by a whole number. So when we have a whole number divided by a unit fraction, we're seeing, if this is 1, we're seeing we have how many holes, right? How many holes do we have? 5. Okay, I'm going to draw 5 holes. And we want to divide each hole into what sized pieces? Thirds. So I want to divide each hole into thirds. And this is when we start thinking like this. There are how many thirds in one hole?
3.
Right, there are 3 thirds in one hole. How many holes does the problem say we have? 5. So how many thirds are there in 5 holes? 15. So whenever we have a whole number and we want to divide it into unit fractions, we're seeing how many of those unit fractions fit inside the number of holes that we have. Make sense? When we have the opposite, we're starting with a unit fraction. We said, okay, we don't have 1 whole this time. If this is 1 whole, how much are we actually starting out with? We're really starting out with 1/3. Let me actually highlight it. We're saying, actually, we only have 1/3. And we want to split that third into how many equal sized pieces? 5 equal-sized pieces. You got it. So 1, 2, 3, 4. And then we have to split these fifths into equal-sized pieces too, into fifths, right? So now my one whole is split into how many equal-sized fractions? 15. Because if I count them, I'll have 15. And one of them is 1 out of 15. So we can think of a whole number divided by a unit fraction, like over here, as seeing how many of the unit fractions fit into that number of wholes. Whereas over here, we're taking a fraction and we're splitting it up into even smaller pieces. Does that make sense? Good. The information given to us says that the perimeter of a square is 1/5 of a meter. Okay, let's stop before I even read what the question's asking. Let's understand what that means. What does perimeter mean? It's the outside. So the perimeter of this table would be if I measured from here to here, and then I added on and measured from there to there, and measured from here to here, and measured from here to here, right? The distance around a 2D figure is its perimeter. So if we know that the perimeter of a square is 1/5 of a meter, what's important about squares? All 4 sides are the same length. That means if I added from here to here, plus here to here, plus here to here, plus here to here, all together, the perimeter is 1/5 of a meter. Well, if I know that, how can I find out how long this side is? How many times did I have to add something up to get to 1/5 of a meter?
4 times.
Yeah, so let's call that side length, L. Okay, it's the first question is asking us to find the length of each side in meters. Well, and draw a picture. So there's a picture. So we know that L plus L plus L plus L equals 1/5 of a meter. Do you agree? Because if the perimeter is 1/5 of a meter, we know that one side plus the next side plus the third side plus the fourth side is 1/5 of a meter. Yes? Okay. What do we know about repeated addition? It's the same thing as? So instead of writing L plus L plus L plus L equals 1/5 of a meter, how could I write that as a multiplication equation if repeated addition is the same thing as multiplication? Samarth?
4 times L equals 1/5.
Yeah, 4 times L equals 1/5 of a meter. I agree. If we know that 4 copies of L is 1/5 of a meter, how can I find out what 1 copy of L is worth? If I were to draw another picture, if this is L, and this is L again, and this is L again, and this is L again, and all together, this is 1/5 of a meter. How can I find out how much just one L is? Kevin?
1/5 divided by 4.
I could use the inverse operation. I know that the inverse of multiplication is division, right? So I can do 1/5 divided by 4 will equal the length. Do you agree? Okay, now let's think back about the patterns and things that we've been noticing. If I have 1/5 and I want to split it into 4 equal-sized portions for each side, right? Will each portion, will 1L, be bigger or smaller than 1/5?
Smaller.
It'll be smaller because I'm taking 1/5 and I'm splitting it up into 4 equal-sized pieces. So will my final answer be a fraction or a whole number? Okay, let's draw a picture to show how we're going to split up 1/5 into 4 equal-sized portions. Are we starting off with an entire whole? No, we're starting off with just 1/5. So draw one whole and split it into fifths. 3, 4. So we can show that this whole thing is one whole, and this right here is 1/5. Now each fifth, we need to divide it into how many equal-sized sections? We're splitting each fifth into what? How many pieces? 4. So go ahead and do that. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Now all together in my entire whole, I've now split that whole into what size units? How many little size fractions do I have? 20. And so I only want one of them. So I have 1/20 of a meter. Does that make sense? So the first part A says, find the length of each side in meters. Well, each side is 1/20 of a meter. Now, part B says, how long is each side in centimeters? We're changing from meters, 1 unit, to another unit, centimeters. So we could call this unit Good. Whenever we do unit conversions, we have to write some thought bubbles in our heads. On our papers. Okay, what's our original units?
Meters.
Okay, 1 meter equals, and we're changing to?
Centimeters.
Good. We also need to write the other one. 1 centimeter equals blank meters, right? Okay, 1 meter equals how many centimeters?
100 centimeters.
Good. So then, 1 centimeter is how much of a meter?
1
1/100th. Good. Okay. We're not going to use both of those. We know that. But writing both will help us not make mistakes when we do our conversions. Make sense? Okay. So here's our answer for part A. Now, whenever we do unit conversions, we write the same format over and over again, right? We start with our original amount of meters. How many meters do we have to start out with? 1/20th of a meter, right? That equals to 1/20th copies of how many meters? 1 meter. Which equals to 1/20th copies of, good, 100 centimeters. And now we're ready to multiply. I'm going to move this way because I have more space this way, okay? So how do I write that as one multiplication equation? 1 times 100 all over 20. Do we have any common factors? What is common? 20 and 100. They're both divisible by?
20.
Good. 100 divided by 20 is?
5.
20 divided by 20 is?
4.
So my new equation is 1 times 5 all over 1, which is?
5.
And what's my units? 5 centimeters. So your answer to part B is 5 centimeters because 1/20th of a meter is equivalent to 5 centimeters as proved by our unit conversions. Make sense? So this is taking what we know, combining a bunch of skills that we know. It's taking how to divide with fractions and whole numbers. It's taking how to do unit conversions and how to multiply fractions. Lots of skills just in one problem.